This lesson is for Advanced Algebra, Lesson 11.1 on polynomials. For the word polynomials, poly, the prefix of the word here, means many, and the nomials part means terms. So we're talking about lots of terms put together. Keep in mind that when you do that, none of the exponents can be negative. We need to do some quick review about the rules for adding versus multiplying with variables. Remember when you add two terms together, like 3x plus 2x, the coefficients, the numbers in front of the variable, are the things that get added, and then the letter just stays the same. If the exponents on these were different, then we would not be able to add them together. When you multiply, the coefficients get multiplied, so that's where we get the 6 from, but then x times x turns into x squared, so the exponents here get added. So it's very important that students remember the rules for multiplying and addition because the rules are different. It's also important that we review from Algebra 1 the idea of doing FOIL. FOIL is when you multiply two binomials together. And we're going to talk about what a binomial is here shortly. But let's take a binomial 2x plus 3 times another one, let's do 3x plus 2. What FOIL does is it's an acronym to help you remember which things get multiplied together. The F in FOIL stands for the first term. So you multiply the first term in the first binomial times the first term in the second binomial. So 2x times 3x, hopefully students know that, just like we just talked about, is 6x squared. Now the O stands for outer or outside, so the terms that are on the complete outside of the terms are 2x and 2. Multiply those together, you get 4x. Now again, since we're multiplying, we don't need to worry about whether or not we have like terms because we just multiply the coefficients and the letters just sit there. The I in FOIL stands for the inside terms, so in this case that would be 3 times 3x. Common mistake here is for kids to say 6x by mistake. Make sure that you're multiplying and not adding. 3 times 3 is 9x. And then the L stands for lasts. It's basically the opposite of the firsts. So whatever is second in each binomial gets multiplied together. So 3 times 2. Common mistake there is for kids, again, to think addition and to get a 5 there by mistake. Usually when you go in FOIL order, if the letters are first and then plain numbers are second, usually the middle two terms are like terms. So you should combine them. Keep in mind that the rules are going to switch now because now you're doing addition and not multiplication. There are no other x squared terms, so you just get 6x squared. The 4x and the 9x get added. The 9 and the 4 are the coefficients. Those get added. 9 plus 4 is 13, and the x stays the same when you're adding. And then you've got the 6 on the end. There's a bunch of vocabulary related to polynomials. What we got here for our answer is a polynomial, and you should be able to name that polynomial using some specific vocabulary words. So that's what we're going to look at next. And I've kind of grouped the vocab words into chunks. Polynomials, again, means many terms put together. There are some specific types of polynomials that have specific names, and those are the single, double, or triple terms that exist. So if you only see one term in a polynomial, it's considered a monomial. If you see two terms put together, then it's a binomial, like bicycle has two wheels. And if it's got three terms in it, then it's considered a trinomial. So that's what we have in our example that we did here. There's 1, 2, 3 terms. Usually it's easiest to figure out how many terms you have by looking at where the plus signs are. The next thing that we talk about in terms of classifying or naming a polynomial is related to the exponents. When you give the degree of a polynomial, you want to grab the term that's got the highest exponent. Keep in mind that there are different names for the different degreed polynomials. If it doesn't have a degree, or if the degree on the exponent is a 1, then it's considered a linear polynomial. If it's got a degree of 2, or if it's being squared and that's the highest exponent, then it's considered a quadratic polynomial. And then you can see you've got cubic is 3, quartic is 4, quintic is 5. Just to point out one quick thing here where kids make mistakes. Notice here that quadratic and quartic both start with Q and sound very similar. It's very common for students to believe a quartic has a degree 2. Please don't make that mistake. That's a very common mistake that students run into. Quadratic is 2, quartic is degree 4. Two ways you can try to remember that. There's 4 quarts in a gallon, and there's 4 quarters in a dollar. So 4 goes with quartic, quadratic goes with 2. When you're working with polynomials, it's extremely important that you always write it in what's called standard form. Standard form means that all the terms are in descending order according to the degree. So if we look at our example here, that is in standard form. The x's here start with the degree of 2, and then they descend after that. So this one is in standard form. It's starting on the left with the x to the second, and then there's a plain x, and then there's no x's at the end. So that one is in order. Some polynomials have a constant, usually at the end, and it's just the name for the number without a variable. So in this case, our constant would have been the 6. And then the leading coefficient is the coefficient of the standard form polynomial. Now be real careful here. When it's in standard form, that means the highest exponent term is in front, and we want the coefficient that's at the beginning. So keep in mind that it's not the highest coefficient, it's just the coefficient that's in the front hand position. So in our case here, we've got 6, 13, and 6 as our coefficients. Well, actually, this 6 is a constant, not a coefficient. So we've got a 6 and a 13. Those are both coefficients on the x's. 13 is the highest one, but we don't care about that. We want to know which one is the leader or which one is in front. So this is in standard form, so the coefficient at the front or in the leading position is the 6. So if we were going to classify or name this polynomial, we would say that it's a quadratic polynomial based on its degree. So it's a quadratic polynomial. But if we can say what type of polynomial it is based on how many terms, then we should say that. So we'll say a quadratic trinomial because there's 3 terms. And then oftentimes they ask you to say what polynomial it's in, meaning what variable you're working with. So in this case we would say a quadratic trinomial in x, because that's the variable that's in it. It's not in every term, but it's the main variable that's showing up. And we'd say that that is the name of this polynomial. That would be the specific way we could describe it. So when you're working with polynomials, always make sure it's in standard form. Make sure you can identify the leading coefficient after you've put it in standard form. Make sure you can identify the degree. The degree will also be related to how you get it in standard form. And then you should be able to name it based on all of those things. Also, try to identify what variable it's in. You won't always have that because sometimes there's multiple variables going on, but usually the main one is the one that you would say that it's in. So let's try a few more examples. If we look at this first example, if we grab the term that's got the highest exponent and put it in front, that'll help us get it into standard form. So we'd say 3x to the 5th. The next term we should see is the 4x squared. And then we would want to put the xy because that still involves any variables. And the 1 should be at the end because he's a constant. Now if we were going to try to name this, we would say degree 5, so we'd call it a quintic polynomial with 4 terms. There is no fancy word for that, so just quintic polynomial with 4 terms. And we'd say that it's in x, I guess, because x is the main variable. Even though there is a y term there, we would still say that it's in x because that's the main one. On the second one here, this one already is in standard form, so we don't need to do any rearranging. And if we were going to name it, we'd say it's still quintic because it's degree 5. It's a trinomial, and it's also in x. This is a quintic trinomial in x. And we should also talk about the leading coefficient here. On the first one, the leading coefficient was the 3. On the second one here, we would say quintic trinomial in x with a leading coefficient of 4, because that's the coefficient at the beginning. On number 3 here, we would also say that this one's in standard form already, because we've got an x cubed, and then the next term has an x squared. So the x's are descending. Because we've got a y here, I don't know that I would necessarily say that it's in x, but it's definitely in standard form. Now let's talk about the degree for a moment. This term has 2 exponents in it, so we would need to add those together to find the degree. So this is still a quintic binomial, because now we only have two terms. Quintic binomial, we wouldn't say that it's in x, but it's okay if you would. And then there are no constants, and the leading coefficient is a 5. On these last two here, it would be in dispute on which way you'd want to deal with it. The x to the fourth and the y term here has a degree 1, but again, because there's two letters put together in the same term, we would say that this term has degree 5. But because this term here has a degree 5 already without having to add, we'd really want this term to be first. So we would do some rearranging here to get this one in the proper format. So notice here that the y's are descending. So we've got 7y to the 5th, 6x to the 4th y. Both terms are degree 5, but overall we would still say that the polynomial has degree 5. Leading coefficient here is a 7, and it's a binomial. You could say here that it's in y, because the y's are technically descending. On the last one here, there would be some dispute on which way it would be in standard form. Typically you want the highest degree termed first, but we also try to deal with things being in alphabetical order if we can at all get it in that format. But because the y to the fourth is higher than the x to the second, we would want to put the y to the fourth first. So again, this would be a quadratic? No, it's a quartic binomial with a leading coefficient of 1, and we wouldn't say that it's either in x or y because both variables appear there. So I'd like you to get some practice writing your own 6th degree polynomial in y, writing your own 2nd degree polynomial with a leading coefficient of 7. Know that there are many different possibilities for what the answers could be here. I'm going to write a few examples here just so you can check your work. Go ahead and try those two right now, pause the video, and then you can check your answers either with your teacher or with the screen. So I've got a couple random examples here that would both qualify for number 6 and number 7. If you're not sure if your answer works or not, feel free to run it by your teacher. The last thing we need to talk about is word problems where you have to create a polynomial from the information. So let's read the question first. On your birthday every year, your grandparents give you $50. Wow, wouldn't that be nice? Until the age of 6, your parents deposit the birthday money into a savings account for you. That savings account earns X annual, which means yearly, interest. Write a polynomial that represents the balance in your account on your 6th birthday. Usually for these types of questions, I write out blanks for myself that represent each birthday. That helps me keep track of all the different terms. So I'm going to have 6 terms all together. And just for the sake of visual reference, I'm going to indicate that this one's my 1st birthday, 2nd birthday, 3rd birthday, and so on. So on my 1st birthday, I get $50 from them. On my 2nd birthday, I get $50, and so on. Now we are writing this polynomial on the 6th birthday, so we're going to pretend that that money is happening or being deposited today. So that means the money that you got on your 5th birthday has been there a year, earning 1 year's worth of interest. The money that you got when you turned 4 has now been in the bank for 2 years, earning 2 years worth of interest. So we'd put X there and we'd raise it to the 2 to represent the fact that it's got twice as much, not twice as much interest, but 2 years worth of interest. And then you can see that that pattern is going to continue until we see that the money that you got when you turned 1 has now been in the bank earning 5 years worth of interest. So now that is a polynomial in standard form that represents how much money is in your account if your $50 you got on your 6th birthday got deposited today. A follow-up question that you might be asked is if the X represents an interest rate that's given as a specific number, like 4.5 for example, you would be able to go ahead and plug that interest rate into your polynomial to actually determine the actual account balance. Keep in mind that when you're given a specific interest rate, you change that interest rate to a decimal by moving the decimal point 2 places to the left, but you also need to add a 1 in front of it. If you don't add the 1 in front, all it's going to tell you is how much interest is in your account, not how much is in your account including interest. So to include the interest and the previous balance, you'd stick a 1 in front. So it's always important when you're doing problems like this, you do 1 plus the percentage to find what the x is. So keep that in mind, that it's always 1 plus the percent to find the actual balance in the account. So then you would be able to type in on your calculator 50, and then you do 1.045 to the fifth, plus the next $50 times 1.045 to the fourth, and so on. And you'd be able to determine the amount in your account.